Okay, so oh, so after you created your project, like I showed in the last video, you will be put on the screen like this, and you will see 4 folders, and we'll be focusing on right now for the header files and the source files. If you already know this, skip it. This is just basic C++ stuff, nothing really important. If you're advanced in C++, I'm just going to talk about the compiler, why we use header files, why we use source files, the purposes of them, function declaration, definition, whatever. Just basic stuff. So now the reason we have header files and source files is because in C++ you have to actually declare a function before you define it. And defining a function is essentially just the implementation of that function. So a declaration might look like this. So void, that's a v, void func, and this is the function name, void func. So a declaration will look like this. It might also be, another example would be int func, int a, and int b. This is another function declaration. So your function declaration is just that. It is just a declaration. Now, when it comes to defining that function, it will look something like this. So you would say void func again. So this would go in the header files. So this would have a .h file extension, and it would go in the header files. Because again, in C++ you have to declare a function because you can define it. And this is all declaration right here on the left. And if you want to define it, you would write that again, except this time you would open brackets and you would obviously give its implementation. So maybe the implementation of this function is to out the letter I, and semicolon and close. So this is defining that function. And I'm gonna get into why we don't do this. So when you declare a function, it tells the compiler the name of the function, its return type, which in this case is integer, its parameters, basic stuff. So the compiler will only build this declaration a single time all around the program. Now I'm going to show what happens if you don't do this, and if you just try to call a function from another CPP file. So let's say we have file1 dot cpp. Okay, so file1 dot cpp, and this this will be a source file. And let's say you have file 2.cpp. Sorry for my handwriting. And let's say in here you define a function. And this function, this is your first time ever working with this function in the whole program. Void func, whatever, and let's out the letter I. The char I, whatever. And you close the function. Now, if you come in and you try to call call the function fun in file2cpp, like this, like how you normally call a function. Oh, sorry. How you normally call a function. So if you just call fun, this will give an error. Now, the reason this will give an error is because of the way the C++ compiler works. So the C++ compiler, it takes both of these files. The C++ compiler takes both of these files on their own. So each CPP file, let's say there's 2 CPP files, file 1, file 2, it will take both of them and it will turn them both into OBJ files. And those are just object files. So this will become file 2 dot obj, and this will become file 1 dot obj. And at the end, so after these become object files, and object files are just assembly code, so its machine code is compiled to machine code so the CPU can understand it. That's how it works. That's how, again, this is a little far beyond that. It's a little beyond that scope. We're kind of past that. So these become machine code, and at the end, I believe it's the linker that combines both of these into one big executable. So whatever, maybe this is keylogger, this is named keylogger, this will become keylogger.exe. Should be two G's, but whatever. So uh, now you're wondering, okay, they both get turned into object files before they combine and make one big executable, so what? And the problem is, when we try to call function here, or fun, the function fun, it has never been declared before. The compiler doesn't know about it. So when this file gets compiled on its own, what will happen is it's going to call this function, and this all happens super quickly, but it doesn't know about this function. It doesn't know what it's never heard of it in the program because, again, it turns each individual CPP file and it compiles it before combining them together. So when you try to call this function right here, it will yield an error, result in an error, because, again, it doesn't know about it. And what will happen is, I believe, I'm not too sure about this, but I believe the C++ compiler will try to build, since there's no declaration, it will try to build these functions. We'll try to build the function fun everywhere it's included. So if you include it here and here, it will build it here. And what will happen is the linker will combine, and this will give a multiple definition error. So that's why we have header files. If we have a header file where we're declaring this function void fun, we can actually give it its definition here, and the declaration will be in the .h file, the header file. So you would make file1.h, and you would put the declaration, and file1.cpp, that's where you define it. And then when you call this function in file2.cpp, that won't give an error because the compiler will know about void fun. It will know its parameters, its return type, its name, its unique symbol. So and that's just why we declare functions. That's the point of the header files. That's the point of the source files. Okay, so now that we know why we have header files and source files, we can actually get into the program, the code, which is why we're here in the first place. So in the source file, I'm gonna make a CPP file, and I'm just gonna call this main. And here, this is where I'm going to run every function, all the code that I'm going to develop in other files to run essentially run the program. So this is just going to be used for function calls. And for now, I'll std out hello world. And we're getting errors obviously because we haven't included iOS stream. Include iOS stream. And we'll run this file or program to make sure everything works fine. And hello world. So, and this is one thing I like to do in the header files. I like to make a file called common.h, and in my common.h file, I just include every single library that, or I'm going to include libraries that I use in every file. So iOS stream is going to be used in every single file. And instead of naming a million libraries in every single file that I'm using, so instead of saying iOS stream here and windows.h here and then saying that again in another file, I just declare it all here. So I include windows.h. Now the reason I'm including windows.h is because this is the library that allows us to interact with Windows APIs, Windows API functions. We can call them, manipulate them. So this is used for Windows API functions. And I just include common.h. And what this will do is it will just bring all the code here. So it's whatever is on this file will go in this file. And If I launch this, it will still work correctly. Yeah. So yeah, that's there. Now I'm gonna make a new header file. I'm gonna call this process info. Process info. And the use case of this file is we are gonna get process ID numbers, process names, etc. I'm not sure what else I'm gonna do here, but I believe that's all I will. Now, the reason we are getting process info is because it's easier if I demonstrate this. So a regular keylogger, we would just log all the keys that is being typed. Super easy, super simple, sure. But here, we will, what our plan is to get all the process IDs. And the process ID is, better if I just show it. The process ID is just a unique identifier of each process. So this, the process ID of 21728 represents SVC host, exe. And every single program that is running in the background or that is running right on your foreground in front of you will have a process ID number. So we want to be getting the process ID number. So PID. So let's just say 1, 2, 3, 4. And we want to be getting program names. So the program name, let's just say chrome.exe. The reason we want this is so when the keys are being logged, so let's say the user's typing A, B, C, D, E, F, whatever, right? They're typing keys on their keyboard. We will actually know the associated program that they are running on. So we will know what process they are typing this on. That will help us be able to monitor them better. Say that, I guess. Because if you're just running a keylogger, you don't know what is being typed in, whatever. But if we know it is being typed in, say, an SSH login on a command prompt, then we will be able to essentially get their SSH login. I mean, I don't know who uses SSH without public key cryptography, but it's still out there. You get the point. So again, this is only used for process ID names and process names, and we're going to be printing that over and over again to while the keylogger is functioning in order for us to get an understanding of what the user is doing. So here, and this is a header file, I'm going to declare, and actually before I do that, I'm going to do if not defined, and I will explain this in a second. If not defined process info h, highlight that, define process info h, and I will declare my function here, and this will be an integer function. So I will call this int process, I guess, just process, int processes, and no parameters for this. Oh, I'm sorry, I don't know why I'm doing that. I messed up my own explanation. So this is again just a declaration, no definition here, just a declaration. And I'm not even too sure, and you see it's saying function definition not found, so the compiler will actually look for a definition of this declared function. So what this does is it says it creates a Unix symbol. I believe, I am not too sure, you can do your own research about this, but C++ is a little complicated. But I believe it makes a new symbol. I read this somewhere. It makes a new symbol called process info h, and it says if process info h not in, let's say, main CPP, for example, we will the code below it will go to main.cpp. But if process info h, the symbol, is defined in main CPP, then the code will not be run, and this will help us prevent multiple definition errors or code repetition, and we'll actually be able to compile our code. So now that we have the declaration of int processes, I'm just going to highlight that. So the declaration of process info is done. Now I'm going to make a source file, add a CPP file if you remember, and I will call this. I will name this the same as our header file. So this will just be processinfo.cpp instead of processinfo.h. And here, this is where our function definition will go. So, and you just wanna, so you see this error? Where is it? 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 Sorry. So, oh, I have no idea where I am. Okay. Oops. So here we are getting a warning. It's saying function definition for process is not found. So we're just gonna say int processes and no parameters here because that goes in the declaration. We're gonna do std out called function. And line. And if you remember what I said about the common.h file, instead of typing iOS stream again, I can just say include common.h. Now save that, and in main.cpp I'm going to call this function, which I have to actually include that file here also. So I have to include processinfo.h, and this is including the declaration of that file. So I'm going to call that function here, processes, and I'm going to run this program. Yep, there was an error. It's not going to tell me what the error is. Okay. Process h main cpp. Try running it again. It's weird. Why is it not telling me what the processes must return a value? Oh, okay. Sorry. So you just want to do return 0 because integer functions in C++ they are required to return a value. So we're just going to run this. And as you can see, hello world is printed, and that function is called, meaning we have called this function from this file correctly. And no build errors, no merge errors happened, whatever. So, yeah. Now we're going to actually get into writing the program. Now, again, these are just, I'm sorry, so these are just our basic libraries we'll be using. For now, I will be adding more later, I believe, at least. But whatever. So now we want to get the process ID for files that are so we want to get the foreground, and we want to get the process ID of that foreground window. Now a window is just, I'm sure you know what a window is. It's just these. So this is a separate window. This is a separate window. And the way Windows works is it calls certain functions when certain things are happening on your screen, when you do certain things. So when this file is here, the get foreground function, there's a way more about like how keyboard focus works, how monitors, not monitors, I'm sorry, how Windows and Windows work. But essentially we'll just be using get foreground window function, and this just retrieves a handle to the foreground window. And foreground just opposite of background. Foreground is just the screen that you can actually see that's on top of this, on top of everything else, and it has your keyboard focus. And keyboard focus just means I can't type here because it doesn't have my keyboard focus, but my keyboard focus is here, so I'm able to type here. And yeah, and a handle is just a special value that represents a window, and in this case it represents the foreground window. And yeah, if you would like more, just go to the Windows documentation. You will get way more than I'm explaining right now. And I believe the get thread or thread process ID is something along those lines. yeah, get window thread process ID, and this retrieves the identifier of the thread that created the specified window, and and optionally the identifier of the process that created the window. And if you remember, PID is the identifier of a process, a unique identifier. So this will actually return us the process ID of a process. So, and the documentation here looks a little weird, but it's pretty straightforward. So first we'll be getting the window, because we want to actually get the foreground window first in order to get the process ID of the foreground window. And in order to do this, we have to, and here in the syntax, this represents handle. HWND is a handle. Handle to the foreground window. And if you remember, handle is just a special value. So basically, we're just storing, I guess, this instance in this handle. Super simple. So we're just going to do HWND and handle. This is part of Windows.h. We're going to call handle, and if you know how static languages like this work, is like C++ work, you have to name something, then equate it to a instance you're calling, like a variable, whatever, a constant, doesn't matter. So we're going to say handle active window, and active window will represent the instance of get foreground. Oops, I misspelled. Get foreground window. I keep forgetting how to get foreground window. So this retrieves a handle to active window, and again, the get foreground window is just a window on top. So now we're storing this here. We want to actually be able to get the process ID of this. So I'm gonna declare a dword process ID. Now the reason we're using dword is because we're working with Windows API, and dword is just a 32-bit unsigned integer for Windows APIs. So I will show in a second also why we can't just use integer here. Actually, might as well just show it right now. And we're gonna say get window thread process ID. Look at that, it's already here. But yeah, it's already here. Okay. And it's just getting process ID. So now the process ID looks for, I believe it's 2 arguments. It could be 2. I'm not too sure. But we want to get the process ID of active window, and active window is representing the foreground window, and we want to store this into process ID and close that. So, and this in C++, this sign, I'm not sure what it's called, but it's just a pointer to a variable's memory location. And the reason, again, now I can explain why we're using dword, is because get window thread process ID, the function itself tries to, I believe, store it into a dword. Because, okay, so now that we have this, I'm going to say, actually before I do that, I'm going to, now we're going to store the title bar of this active window into a variable, and we're going to print this variable. Now the title bar of a window is exactly what it sounds like, right here, the title bar. So if I were using, say, mail, it would say mail, because that is, or whatever the title bar is in mail. So right here, clipchamp, Microsoft clipchamp is the title bar. And we'll see why this is helpful in a second. And the function we'll be using to do this is get window text A. And get window text A copies the text of a specified Windows title bar into a buffer. And I'll show what this looks like in a second. So first we're going to declare a char called window title with 126 elements. And we're going to use the get window text A function, and we're going to get the title bar of our current active window. So the foreground, and we just call active window, and we store it into window title. And as you can see, it takes 3 arguments: the handle to a window, which in this case is the handle to the foreground window, and where it's being stored, out. And again, if you look at the documentation, you'll really understand how I'm using these functions, why I'm using these functions, and etc. And int and max count. Now, n max count is just going to tell us the number, is going to tell that function, get window text a, the number of characters to copy to the buffer. So, and I'm not really sure why. This could be used to prevent buffer overflows, whatever. So we're gonna basically tell it the max value it can copy is 126, and we can do that with the size of function, and we just say size of window title. So we're telling it only copy 126 characters maximum. And after we do this, we're gonna just out std out. We're gonna std out PID, which means process ID. We're gonna out the process ID, and that is stored in process ID, if you remember. And std and L. Then we're gonna go ahead and print, and out just means print. I mix those up all the time, and we're just gonna out the actual window title of the foreground window, and I'm gonna show what this looks like in a second. And I'll say, actually, we don't even need to do that because we know how the code works, or at least, yeah. So we're just gonna out window title end line. And if I go ahead and run this, should give no errors, I believe. Okay, so this should go in a while loop. So while true. And let me make sure this is actually being called. Yep. Delete hello world. Run this process. Yep. Okay. So should probably make the sleep a little bit. We can use just the regular sleep. I believe that is in milliseconds. I'm not sure. Okay. So now if I go here, it's still way too quick. Let's do 8,000. So if I go here now, as you can see, the title bar of this window is showing. So, and actually, just to make this look nicer right now, I'm going to std out, or just std and L. Oh, maybe std out, std and L. Yeah. Okay. So when I run this and say I open Firefox, you are able to see exactly what program they're running. So what if I open, say, a command prompt? You'll be able to see they're on command prompt. What if I'm running SSH? That doesn't work, but you get the gist of it. And to know if they're using SSH, there's other ways. And I'll be using, say, Facebook for an example. Log in or sign up. So if a user comes in and types their keys, and you are logging their keys, you will know they're logging into Facebook or making an account. Or say a bank. Let's go to Wells Fargo, for example. As you can see, it is clearly saying online banking services. So if they type anything here, you know exactly what they're typing, where they're typing it. And we get the process ID. of that foreground window. So yeah,